Okay, guys, Ms. Robertson again, and this time we're going to solve rational inequalities and we're going to write our solution in interval notation. Step 1, factor everything. That's the general theme of this unit, factor, factor, factor. The numerator is already factored. The denominator, we can factor it, what two things multiply together to get 9 and add together to get -6. That would be -3 and -3. And once we have everything factored, then we want to decide what are our zeros. The zeros come from our numerator. So we're going to take the x plus 7 and set that equal to 0 and solve. So we get x equals -7. Next, we're going to look at our undefined points. The places or the x's that when we plug them in cause us to divide by 0 or give us an undefined function. So we're going to set our denominator and set it equal to 0 and solve. So we're going to take this x minus 3 equals 0 and x minus 3 equals 0. Those are the same. So we're going to end up with x equals 3 and x equals 3. Then we're going to go to our number line. And we're going to put all of these points on our number line. First we have -7, and then we have +3, excuse me. All right, to determine whether or not we use open circles or closed circles depends on whether or not we include the points. Okay, undefined points. Will we ever include undefined points? No, because they're undefined. So undefined points are always going to be open circle. Will we include zeros? Now, this question will have a different answer depending on your problem. So look at the sign right here. This says less than or equal to 0. Are we allowed to include 0? Yes. So we will use a closed circle. Once we have determined that, we're going to go to our calculator and we are going to plug in our function into y equals. Make sure that you put your original function and you use parentheses. You can see that I have the entire numerator in parentheses and the entire denominator in parentheses. I'm going to go to my table and I'm going to test some points. I want to test a point between -infinity and -7. So I'm going to choose a number between those 2 points, which is really anything smaller than -7. I kind of like to change my table to ask. I just think it's easier. So I can plug in whatever I want. So -8. And I get an answer that is negative. So this answer is negative. Now I'm going to go back to my calculator and I'm going to plug in a point between -7 and 3. So 0 works. And I get an answer that is positive. Next, I'm going to plug in something greater than 3, anything between 3 and infinity, so 5. And I get a positive answer as well. The question wants to know, when is this function less than or equal to 0? So less than or equal to 0 would be all the values that are negative. So these are the values that would satisfy this inequality. That is our solution interval. So we're going to write our solution in interval notation, so -infinity to -7, and we're going to use a bracket. The reason we use a bracket is because we are allowed to use -7. Okay, let's do one more. Let's look at number 5. I'll do number 5, and then I'll let you do the rest on your own. Okay, so number 5, step 1, factor everything. So we have a numerator with x squared and x, so I can factor an x out, and I'm left with x plus 3. A denominator, that's the difference of 2 squares. So x plus 2 and x minus 2, and that's going to be greater than or equal to 0. First of all, figure out what your zeros are. X equals 0 and x plus 3 equals 0. So this is x equals -3. So those are my 2 zeros. Next, figure out what your undefined points are. So I'm going to take my entire denominator. So this x plus 2 equals 0 and x minus 2 equals 0. And find those undefined points. So this is x equals -2 and x equals +2. Next, I'm going to go to my number line. And I'm going to plug all those points into my number line. Make sure you're in numerical order. So -3, -2, 0, and 2. This is positive infinity and this is negative infinity. And now we're going to go to our calculator and we're going to put in our original function. So parentheses x squared plus 3x, close parentheses, divided by x squared minus 4. Ooh, I need a parenthesis there. I did that wrong. So parenthesis, here we go. I think I got it right, but let me double check. I'm not trusting myself. Okay, looks good to me. And we're going to go to our table and we're going to ask ourselves about these points. So if you notice, I have a clear table because I'm on ask. Ask your teacher how to get there. Second window or second table set will get you there. And I'm going to plug in a point that's between negative infinity and -3. So -4. And I get positive. I plug in a point between -3 and -2, so -2.5. So I get negative. Between 0 and -2, so -1 works. So I get positive. Between 0 and 2, 1's a good choice. And greater than 2, 3. So I get positive. Okay, in order to determine which intervals we want, we go back and look at the problem. The problem says, when is my function greater than 0? So those would be all my positives. So here, here, and here. The one thing I forgot to do is make closed circles and open circles. So let's go back and do that. It's easy to do. My zeros are here. Am I allowed to include them? It all depends on the question. The question says greater than 0. It does not say greater than or equal to 0. So we are not allowed to include our zeros in this question. So they are all going to be open circles. Undefined points are always not included. Zeros for this particular question are not included as well. So all of these will be open circles. I can't include any of those numbers. Now I'm ready to write my answer in interval notation. So this is my first interval from negative infinity to -3. Parentheses on everything. Union with -2 to 0. Union with 2 to positive infinity. So my solution is any x in any of these three intervals. If I plug it in, I'll get a true statement. All right, good luck. Study for the test tomorrow.